Welcome to the presentation for Mechanics Lab 3. We are section 7, group number 2, and these are our tubes for our instrument. First off, we have C7. We measured it out to 2.18 kilohertz. The theoretical amount would be 2.09 kilohertz. Our second note is E flat 7 right here. We measured the frequency at 2.6 kilohertz. The actual amount should be around 2.64 kilohertz. Third up, we have F7, which is 2.79 kilohertz, and right on the money for what the theoretical is. And G7, 3.10 kilohertz, while the theoretical is supposed to be 3.14 kilohertz. We'll then show on screen here all of our values. Whoops.
There we go.
Yeah, we'll plan.
Okay.
Right. Group 7's rendition of Tequila.
Tequila.
Hey. So in the experiment we just showed you, we got all of these values. But what is the theory behind this? Well, first off, we need to look at the parts that we made. They are experiencing transverse vibration. Now, given the last lab, we have already calculated what the natural frequencies are for the material we are testing. This is using the natural frequency here, which is 22.4. That's the first one. We can then calculate out using the modulus of steel, the moment of inertia for the area, and a whole bunch of different values to figure out what the frequency we'll actually see is. The reason that this is important is we want to play, let's say, G7. We know that the theoretical frequency will be here. Now, we're able to take that theoretical frequency and mashing around all of the different values, get the length value that we're looking for. Doing this multiple different times, we can cut off all of the pipes at the exact length we're looking for, and just crunching some numbers, boom, we got our pipes. Now, the reason that this equation is able to work is, like I said earlier, we are using transverse vibration by hitting the pipes while they're hanging. This is very similar to this situation, except we're putting it on a loop. Now, transverse vibration is able to be displayed using the stiffness coefficient here, getting us a natural frequency, something that we're able to learn in vibrations class. But the problem with all of these numbers is that they don't take into account density, because we're looking for a specific length. So we have to take the mass in this, extrapolate it out with density, bam, boom, mix it all together, and we're right back into that original equation. So hopefully this explains to you in quick and rough terms how we're able to take this basic formula for finding out the natural frequencies and the frequencies we're hoping to observe into the specific lengths of the pipes that we cut today.